Assalamualaikum and hi, I am Dini. I will start our video presentation which is about linear approximation. The objective for this topic is to calculate the differential of a function. Other than that, to use differentials to approximate values for expression and to use differential to approximate change in the value such as area and volume. The equation for linear approximation is fx equals to fa plus f prime a multiplied by x minus a, while the differential form of the derivative is dy equals to f prime multiplied by x and dx.
We have seen that a curve lies very close to its tangent line near the point of the tangency. In fact, by zooming inwards, a point on the graph of differentiable functions, we notice that the graph looks more and more like its tangent line. This observation is the basis for a method of finding approximate values of functions. And the idea is it might be easy to calculate the value fa of a functions, but it seems so difficult or even more impossible to compute nearby the value of f. So, we settle for the easily for computed values of the linear function L whose graph is tangent line of f at AFA. Let us see figure number 1. In other words, we use the tangent line at AFA as an approximation to the curve y equal fx when x is near a. An equation of this tangent line is y equal fa plus f prime a multiplied by x minus a, and the approximation fx equal fa plus f prime a multiplied by x minus a is called the linear approximation of tangent line approximation of f at a.
So let me explain about example 1. The question asks to find the linearization of the function fx equal to third x plus 3 at a equal to 1 and use it approximate the number third 3.98 and third 4.05. Are these approximation overestimate or underestimate? So let's go to the solution. So first we need to use the derivative. So fx equal to the x plus 3 power of 1 over 2. If we differentiate this equation and we get this, why we get 1 over 2 here? Because the power we need go in the front of the equation and it's got a 1 over 2 x plus 3 and power negative 1 over 2. This need to minus 1 and we get the answer. This the answer. So we see that indeed the tangent line approximation is a good approximation to the given function when x is near 1. We also see that our approximations are overestimated because the tangent line lies above the curve. So we see that indeed the tangent line approximation is a good approximation to the given function when x near to 1. We also see that our approximation are overestimated because the tangent line lies above the curve. Of course, a calculator could give us approximation for say 3.98 and say 4.05, but the linear approximation give an approximation over an entire interval. Notice from this table and also figure 2 that I explained earlier, that the tangent line approximation gives good estimate when s is close to 1, but the accuracy of the approximation deteriorates when s is further away from 1. So we can see two lines here, which is a blue line and a pink line.
I'm tired already. Yay!
Yes, Dini? What happened?
I don't understand much about linear approximation. Can you teach me more about this topic?
Let me see. I guess I can do it. Let me show you the solution. Let's go.
So the question is, using the linear approximation of fs equal to cube root s, find the linear approximation of cube root 7. There are 4 choices of the answer. The first one is 1.9367, the second one is 1.9167, and the third one is 1.9129, and the last one is 1.8832. So the first one is, we need to assume a function according to the linear approximation or tangent line approximation of a radical number. The method used for the calculation, the approximation, is based on the concept of derivative or differentiation. The formula used for tangent line approximation is fs equal to fa plus s minus a multiplied with f prime a, where a is the nearest perfect cube root number of the number inside the radical. So this first one, we have to consider the function fs equal to cube root s and then simplify the equation. So you will get s power of 1/3, and then let a equals to 8 be the nearest perfect cube root number to the number 7. Also, after that, we need to find the approximation of f at a equals to 8. And the first thing we have to do is calculate the first derivative of differentiate of the function. So we can write it as f prime s equal to differentiate of the equation, that is s power of 1/3, and then for the differentiate of the equation s power of 1/3, you have to bring it in front of the s, and then the power you should minus with 1. So the answer is 1/3s power of negative 2/3. After that, we have to find the linear approximation of f at a equals to 8 by using the formula ls equal to fa plus s minus a multiplied with f prime a. We can write it ls equal to f, substitute the a, and then we will get f 8 plus s minus 8, and then multiply f with f prime 8, and then you will get cube root 8 plus s minus 8 multiplied with 1/3 8 and the power of negative 2/3. Then simplify the equation, and then you will get 2 plus 1/12 multiplied with s minus 8. And then now calculate the linear approximation of cube root 7 by substituting x equal to 7 into the obtained linear function. So linear function that we obtained just now is ls equal to 2 plus 1/12 multiply with x minus 8, and then we will get L7 equals to 2 plus 1 over 12. Replace the x by 7, and then in the bracket you will get 7 minus 8. Solve the equation, then you will get the answer is 1.9167. So the linear approximation of cube root 7 is approximately 1.9167. So the option for this question is B. I hope you all understand the solution for this question. Thanks for watching. Bye.